You guys hear me out there okay? Yay. All right, it's 11 a.m. The witching hour is upon us. Where is the rest of the class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 out of 28. So it's not just me. That's reassuring that it's your other classes too, but what's going on? They're all still in the hardware systems lab? Okay. All right. Numbers are building. Well, good deal. I'm going to proceed anyway. Are there any questions on the assignment that you turned in? How'd it go? Good? We get good results? Somewhat good results. Any technical questions about how to solve the problem or weird stuff that you found at the end? Did TA-Bot do its thing? Give you good results? Michael?
So like in the future, would you have like for the test cases of TA-Bot, would you have like input code? I don't know, just because I just had trouble knowing what some of the tests wanted.
Oh, yeah. So this one I didn't put very many test inputs on the spec because I was in a hurry, so I didn't do that. But yeah, I usually like to give you a sampling of those, and if there were specific test cases in this one that people didn't understand and they asked about, I was happy to show them what the input was. But yeah, I'll try to give you more valid test input. But also as you make your way through more advanced courses, it's going to be expected more and more that you are able to develop your own test cases, right? Because once you're out of here in the real world, when you're asked to build software for money, very rarely do people give you the test cases, right? It's your job to also build the tests to figure out if your software does what it's supposed to do. And so even the written specifications I'm giving you with detailed examples are more precise than what you will normally be given in a real job in this, right? Where you're expected to actually refine the specifications and develop the test data. So you should also be developing your own test cases, not just assuming that all of TA-Bots are all the test cases you need to worry about, right? But that's a lot to throw on you while you're still trying to figure out data structures. So yeah, I'm happy to continue. Katie, what's going on? I just looked over and Katie's under the desk, huh? That's we're off to a very poor start in the class today. 1/3 of the students are missing, and some of them that are here are underneath the tables. So, yeah, no, power cord. Yeah, I get it. That makes total sense now. Any other questions about the outgoing assignment? Okay, so the reading quiz for the maps chapter is posted, and that's due Monday. And Mr. Osterberg just pointed out to me about 10 minutes ago that that chapter does not exist in the previous edition of the textbook. So if any of you still have the 3rd edition of our textbook instead of the 4th edition, most of the content for this next reading quiz is in section 10.6 in the older edition of the book. That's where it talks about hashing. And that's the whole second half of this new 4th edition maps chapter. All right, so take a look at that section if you're still working out of an older section of the book. So at the beginning of the semester, I promised a final project during the final sequence of the course. And guess what? It's November. We're there. And so the other data structures sections actually introduced the final project on Wednesday, 2 days ago. So I'm late. I'm sorry. But we are also going to follow the same final project structure that Dr. Praveen and Dr. Satish's sections are following. So here is the final project. Let me share my screen out here. This is linked off of the course web page if you would like to follow along in your own browser. Data structures. So it's both linked here under Start Final Projects and here, Final Projects. So here's the deal. Imagine you are hired by a startup company, Restaurant Advisor, like TripAdvisor, but more exclusively catered for restaurants. So the idea is to create a central place for customers to write reviews about restaurants they've dined in. And also, we want to be able to allow online ordering of food. We're going to skip the whole section about worrying about delivery because that involves tie-ins with, you know, Uber or some other kind of third-party service. So that's just outside the scope of this. All right, so it's only reviews for restaurants and the ability to order menu off their items off their menu for pickup. All right, you may not be able to do all those things. That's okay. Pick a reasonable subset. At a minimum, you should be able to track the different restaurants. Customers should be able to log in, view the different restaurants, and provide a rating for the restaurants. All right, so the ordering is a little bit more outside the scope of the bare minimum. Each restaurant should have a unique system-generated ID. We also need name, address, phone number, email, hours of operation, types of cuisine, type of dining, price range, food items, and the price of the food item. All right, the types are fast food, casual, dining, family, and fine dining. All right, and here are the various cuisines that we're going to consider. So, teams. The other data structures sections are forming new teams for this, but you guys are already in teams, so just stick with those. If we have anybody that's still unteamed after the shakeup, after the midterm exam, if I think we have an even number of students in each one of the sections here, so I think it should work out. But a small number of 3-person teams are allowable if there are floaters that aren't already assigned to a pair. All right, but for the most part, I'm assuming pairs of you. Our goal here is to produce a Java program with a user interface. So I'm going to spend a chunk of the lecture time next week and the week after talking about JavaFX, which is sort of the follow-on to the Swing libraries to do some basic graphical user interface stuff. All that stuff is not in our textbook, but it actually is in the previous textbook for those of you who've taken the Intro to Java course, right? There's stuff in there about GUI chapters. You probably skipped them if you took 1020 for me, for example, but there is some references there. But then also, more importantly, there's a link to a bunch of helpful references and tutorials down here at the bottom, all right? So we're going to go through some of that next week, but also there's additional resources, both in other books that you probably have already, and of course on the web there's tons of stuff. So this final project is going to have a bunch of milestones along the way. The first one is easy, but it's next week, Wednesday. All right, so instead of a binary search tree project due next Wednesday, there's going to be this, a market research and mock-up design. And let me point out right away, these should not be turned in through the electronic turn-in command on Morbius. That's for Java code. This is going to be a document. So submit it through the D2L Dropbox. I'm going to open up a Dropbox, and I'm going to make it a team Dropbox so that both members of each team can see who's in there. So if any teams are shifting or aren't finalized yet, please let me know that by Monday so that I can set up the D2L Dropbox to recognize the teams correctly. Okay? Otherwise, I'm going to go off of whoever your partner was in the work you just submitted on Wednesday for the last project. All right? So let me know if any of those change. But by the end of the day, next week, Wednesday, I would like you to put together this market research and mock-up design. Guess what? There's no coding involved in this part. Yeah, I know. I have to use like human skills and write in English, actual coherent. I know, I see shivers passing through some of you. Don't worry, there's plenty of code in here, but not for the first deliverable. All right, so first we need to do a survey of the field, identify the competitors. So take a look at some of these other existing systems, Grubhub, Uber Eats, ChowNow, that do some of these same things. Allow customers to review restaurants. Some of them allow you to order food, right? So take a look at what those other sites are doing to get some ideas for what functionality they have, how they do it, what they don't do, how they lay out their site, that sort of thing. All right? And so part of the goal here is to actually write up in English a brief summary of what you see that's out there that does this kind of work. All right? That's always the first step when we're trying to devise a new chunk of software, is to figure out who are the competitors and what does their software do, all right? Survey the competition designs and include a report of what is available out there and what features you can realistically implement by the end of this semester. So this is an estimation task. You've been coding all semester long. I think I've given you some pretty challenging, aggressively challenging projects to try to test out what you can accomplish. You know how much time it's taking you to accomplish those kinds of tasks. That said, the ability to look at a software design and make an educated guess about how long it will take us to accomplish building that is much more an art than a science and takes a lot of experience that for the most part, none of you will have yet, right? So this is a guesstimate. I want you to make a reasonable guesstimate at what you think you can accomplish. This is not written in stone. You will not be graded slavishly against how much of this you actually accomplish by a month from now. But I want you to start practicing this skill that computer scientists develop to try to figure out how much they can get done in the allowable amount of time. All right? It's still a 3-credit course. I'm still expecting you're putting in 9, 10 hours outside of class towards your work in this class. There's 2 of you working for the next 5 weeks, basically. So that's 100 person hours worth of labor to put into a project. That's a serious chunk of work that you can get done in that amount of time, right? So be ambitious, but try to be realistic, okay? And then use one of these professional mock-up generators down at the bottom. These are just online sites that help you quickly mock up what an actual graphical user interface will look like. Michael.
So will there be other projects that we're supposed to be working on while we're trying to work on this final project?
I'm envisioning a few other small programming exercises on binary search trees and hash maps, but they will be nowhere near the scope or pace of the weekly projects that we've been doing up till now, because I expect most of your time is going to go towards this. But I don't want you to go into the final exam and face questions on binary search trees and hash maps without having any opportunity to code those things. So I'm probably going to give you a bunch of little programming chunks that'll be much smaller in scope and have longer timelines. So I'm envisioning your next programming assignment to be due. So we've got a deliverable here on the 7th, and then this is basically a week and a half out from that. I think in the intervening Wednesday, there'll probably be a small chunk of code related to binary search trees that I'll put out there. But I expect that those problems will take you like an hour. All right? Now, I said that, but I realize that what takes me like half an hour to code usually takes you guys about 5 hours to code. So I do have a sort of approximate expansion factor in my head when I say that. So I'm aiming for something that I can code in about 10 minutes that I'm going to give to you as an assignment to work on in like an hour worth of time, so that you've got some practice actually working with all the data structures we're doing in this last third of the semester, but I'm not giving you big projects around. Now, you may find that you need to use some of these data structures we're talking about in the last third of the semester in your project, which would be a wonderful outcome pedagogically for me. I would love if that happens to be the way this works out. But I suspect, given the nature of this and the fact that we don't have really any efficiency concerns, you will find that you need nothing more complex than the data structures we have already covered to this point to implement this kind of system, right? Your restaurant menu review system is not going to cry out for binary search trees in order to make it work. So that's why there's going to be a few other little programming exercises along the way. Okay, Jarrett?
So if we do end up using some sort of data structure in this, do we have to use something we wrote in class, or can we use a Java-based one?
No, you can use you may use anything that's in the Java libraries. You may use any of the textbook code. You may use code that you find laying on the street. Do give credit to your sources, right? Don't just slurp in somebody else's source code and claim it as your own, But yeah, the door is wide open here. This is an open-ended project, and so use the resources that you can find and that are useful to you. Do not submit someone else's restaurant ordering system, right? That's obviously going to land us in a bad place. But all right, any questions about this first deliverable before I move on and talk about some of the later deliverables? Okay, so far so good. So the Dropbox will be open for that, and it will be due by the end of the day, 11:59 p.m. next week, Wednesday, which is the 7th. All right. So GUI design with some features, November 18th, which if my calendar is correct, I think Praveen put down a Sunday for that. Is that right? Is that a Sunday? Yeah, so I usually don't like to assign work to be due on Sundays. So let's think of it this way. This is really due on Friday, the 16th, but if you don't get it done until the end of the weekend, that will be fine. You like that better? Does that sound less like I'm giving you homework that's due on a weekend? Okay, yeah, because I don't intend to work to help you on Saturday or Sunday, so I'm assuming that you're going to be done on Friday, but I will not actually look at it to begin evaluating it until Monday the 19th. So, graphical user interface design with some features. Write a basic prototype of the application that displays the overall graphical user interface, and either hard code some simple inputs so it doesn't have to be full featured, right? So you can make it so that there's already a fixed number of restaurants just to demonstrate what it's going to look like, or food items that are on the system, and then take screenshots of that and include them in your report, as well as upload your source code. All right, so this is not a final version of the source code. There's no like TA-bot test suite for it, but I want to see what you're writing so that I can get a feel for the size of it and the complexity of it, and whether or not you're writing one gigantic 5,000-line main program or breaking it up into a bunch of smaller helper classes and helper methods that are going to make it tractable. All right? So make good decisions as you are coding this. You need to live with this code for like 5 weeks. So objects, methods, well-named variables, perhaps interfaces and data structures. These I commend to you as a way to actually succeed in what we're trying to do. Graphical user interface design with most features. All right, so this is our third milestone, December 2. Again, I think that's technically a Sunday, so pretend in your head it's due at the end of the month, November 30th, the Friday, right? But in fact, you have the weekend if you need it. Prototype the application that displays the GUI with most of the functionality implemented. Highlight the different data structures that you have used. And you can use ArrayList, QStack, HashMap, right? Any of the ones that are in the actual Java collections framework are fair game. Again, screenshots as well as your source code. All right, so the reports here don't need to be gigantic. Right? I don't need like a 5-page essay on how you feel about your application, right? I'm looking for a quick and dirty technical description of here's what we have working, here's the data structures we use to make it work, right? So basically, so I can get a feel for what I should look at in your source code that you feel exemplifies the course content that we've been talking about. All right? The goal here is not to overwhelm me with pages of print that you have generated. Please do not do that. There will be no bonus points for length or weight in these reports. Succinct, clear reports will get better grades. Yes, Nicholas.
So will we have like the restaurants that like people are going to be reviewing and looking at? They're all going to be in this. Are those going to be hard coded into like some sort of like text file that like this reads from that we can keep adding more restaurants and like information about that, or is that something that we initially have to enter?
It's up to you.
Okay.
Yes, you can do that. That would be great. Or you could make it part of the interface that people are able to add in restaurants, right? And add in all that information. That would be a useful feature to have, right? That's up to you. And that's part of your estimate of what you think you can get done in the time that you have allowed for this. Right? But no, I'm not setting down how that has to work. This is your design challenge. All right, December 3rd and 5th. Wait, December 3rd and 5th. This is what I get for not proofreading Provian's work. What days are those? That's a Monday and a Wednesday. When is the last day of class? Is it the 7th or is it the 14th? It's that Friday the 7th. Prototype presentation slides. Shared presentation at the following link. Yeah, I'm not sure what he's going with there. Yeah, that doesn't seem right. So we also have a problem that the other sections don't have because we are not 28 students. We are 65 students, right? So in fact, that plays to your advantage in one distinct way. We do not have time for all the groups to actually present their work back to the whole class, right? It would take like 4 class periods to cover everybody, even if it went optimally well. So instead, these final presentations, I'm going to have you produce some slides with screenshots that show what it is that you've built. But I want each team to actually produce a small YouTube video of them presenting their slides. All right? We all have the technology to do this, right? I'm not talking fancy here. There doesn't need to be video or special effects or editing. I'm talking about a voice while it goes through the slides. That's all. Now, if you want to do anything special, I guess feel free. If you have that much extra time the week before finals, knock yourselves out if that's the thing that you are excited about. But the minimum I'm expecting is a short 3 to 4 minute YouTube video with like 3 or 4 slides showing off, here's what we built, here's the screens we're most proud of, here's what it does. Natalie.
So is that going to be due on the 3rd or the 5th?
I'm going to go with the 5th. All right, Jarrett?
So there seems to be a very large variation in what the final products could look like for all the groups.
True.
So what are you basing on? Do you have a baseline that you're getting at, or is it going to be relative? Because someone could go all out and create this awesome thing, and then the rest of the people could have just done baseline. So do you have like a certain level that you'd like us to at least reach? Because there's, like you just said to his question, you could have a subset of restaurants in there, or you could program that you could add them in there. So like, what should we at least reach?
So there's some description of that up a little bit higher, right? At a minimum, you need to be able to log into a system, be able to find restaurants and view and add reviews for them, right? So that's a bare minimum. I think, if you're able to do that and produce an interface that's workable and that you can actually demonstrate screenshots for, I think that's going to get you 70 out of 100, right? That's going to get you a passing grade on the assignment for sure. And then the remaining 30% is going to be for awesomeness, pretty much, right? So, stretch a little bit beyond that, get some basic menu stuff working, have some fixed restaurants that are already in there with, pick 10, 15 items off the menus of the 5 closest restaurants to campus that you actually go to. All that stuff is online. You can copy paste it, straight into a text file or whatever you're going to do. Make that be a fixed part of the system. That's going to be just great. If you've got more time and it saves you time to actually add the parts for entering new restaurant details, feel free. That's something you can certainly brag about in the final presentation. It'll be worth some points, but it's not a requirement. All right, so there's lots of different ways that you can add value to your particular implementation, well beyond even the ones that I could enumerate if I was going to sit here and imagine them. And that's part of the fun of having an open-ended project like this is I can't wait to see what kind of crazy things you guys are going to come up with as features that are achievable in the time that's allowed. And so I'm excited to see where you can go with that. All right. So final report, I believe. This is the Sunday before exams start. Yeah, right. So that's not a real thing. This will be due basically the last day of class, right? So application description, motivation. So this is stuff that you can pull from the earlier deliverables, right? You're basically glomming together the pieces that you did along the way. Why you're doing this, what the competitors look like, the description of your prototype. These are all pieces you'll have turned in along the way. You just need to put them together, fix the typos, make it sound like a coherent story. A brief user manual for how the system is set up, describe the application using your screenshots, highlight the relevant technical details for how you did it, right? Questions? We've got lots of time to talk about these later deliverables as we go, but I want to give you a good roadmap of where we're going for the last, well, we've got 40% of the course left, pretty much, right? So this is what we're going to do with the last chunk, with most of our time. Questions? Katie?
Can you talk about JavaFX for a little bit?
Not today, no. I got stuff I got to finish first in binary search trees. But I'm planning to do that on either Monday or Wednesday. Right? Since you don't actually need any of that part until the second deliverable, I've got a little time to learn how to use it first, and then to try to teach you how to use it. Feel free to go look at those tutorials first so that you can help correct me when I'm trying to present this to you next week. I got to tell you, I'm an embedded systems guy. Most of the software that I write is for devices that do not have a screen. So graphical user interface programming, not my strong suit, not my passion. Mostly I've tried to avoid it like the plague as much as possible. So bear in mind that you're going to receive an introduction to JavaFX from that kind of computer science professor who views this graphical user interface thing as a passing fad that people will get sick of and return to their embedded devices anytime now. So you should absolutely seek other resources to show you how to do cool stuff with GUI libraries, because I am not the guy that's going to show that to you. I'm going to show you how to establish a basic thing with some buttons and some text boxes that will allow you to interoperate with your program, right? And that's where I'm going to stop and hand the rest off to you guys. Okay? I'm the professor that skips the optional chapters in GUI design in every textbook that I've ever taught out of. Like, no, you don't. Go learn that on your own. This is not important to us. Which is not true, but it's not important to me, and I have the ability to do that because I have tenure. So, any other questions? It's a very important thing that you should definitely learn before you leave Marquette from somebody else. But Praveen designed the project, and so there's a GUI on it. For me, it would have been like make a text-based thing that processes the orders and sends them out to the internet nodes, right? I totally would have done a back-end thing where there was no interface at all, but that's me, right? So I build infrastructure, not interfaces. Other questions? All right, then. Let us return to the drudgery of the binary search tree. No, binary search trees are lovely, right? We enjoy binary search trees. Where were we? Does anybody remember? Because I do not. It's all kind of a pleasant blur. Oh, I see. So we'd done a recursive size method, and we talked about a recursive contains method, right? Did I actually finish this, or is this just like stub code here? Oh, no. We talked about doing get and how it was basically the same template as contains, except instead of returning the Boolean, we'd return the actual item you were looking for, right? All right, I'm not going to write the code for that. So I think we were down to the iterators, is that right? The traversals? Yeah, this is a good time here. This guy, right. All right. So, for context, once again, our goal here in this getIterator method is to return an iterator object that's going to allow us to loop through all the items that are stored in this binary search tree. But the tricky part here, the difference from all the previous iterators that we've looked at, is that trees have these different notions of order. Right? We've got pre-order, we've got in-order, and we've got post-order versions of traversals. And we want to give the user of this data structure, we don't want to prejudge which kind of traversal is going to be important to them for a particular task. We want to give them the ability to order up which kind of traversal they want. And so they pass that in as a parameter, and based on that parameter, we give them the iterator that's going to go through the tree nodes in that particular order, right? So it's like one of the previous iterators that we've seen on steroids. So we need to have a queue that's going to actually represent the nodes, because we're basically going to take the tree nodes and pull them out and put them into a queue that then the iterator is going to go through that queue in order, right? And so our job is to figure out the order in which we need to put the nodes of the binary search tree into the queue in order to encode the results of that traversal. Does that make sense? So if I've got, if I've got my tree nodes, why are the bells going off? Am I the only one hearing that? Does that happen at 11:30 every class? Yeah, right. This is unusual that all the bells are going off at 11:30, right? Yeah, okay. And I'm not hearing this? You're hearing it too? Okay, good, just checking. So this is my simple tree, right? So I have a choice of 3 possible iterators that can come out of this. And what we're going to return is one of these 3. So I've got my pre-order iterator, my in-order iterator, and my post-order iterator. And depending upon which of those 3 types I call for when I call this getIterator method, the result is going to be a queue. So these are each, oh boy, that was terrible. Can you read that at all? I can't read that. Let's just try that again. So remember our queue data structure from what? 3 chapters ago. Seems like a lifetime ago. Good old first in, first out. So we're going to build one of these queues to give back. That's going to be what drives our iterator. And if it was a pre-order iterator, what's the order that the nodes are going to be in the queue if it's pre-order? Take a moment and confer with a neighbor. We'll have 3 choices here. Pre-order iterator. All right? Hold that answer in your head. The middle one's going to be the in-order iterator. What's the order of the nodes for the in-order iterator? Confer with a partner. All right? Hold that answer in your head. Last but not least, you'll never guess what comes last. The post-order iterator. Very good, very good. Confer with the partner. What's the order of nodes in the post-order iterator? Yes, if you're getting a node that is not A, B, or C, you have taken a wrong turn. That's correct. Pre, in, and post. All right, all together. What is the first node out of my pre-order iterator queue? A. Second node, B, and C. Great. My in-order iterator is going to do B, A, and C. And my post-order iterator is going to do B, C, and A. Right? Okay, so that's what we're building down here. The code that produces one of these 3 queues and returns it. So we're going to have ourselves a queue. This is going to be the linked queue from way back when of type T, whatever that generic type is. And so equal to a new linked queue. Go ahead and allocate it right away. Links, so we don't need to worry about how many nodes there are because it can just grow as we insert more stuff into it. So what we do here depends entirely upon this order type. And the order type's got to be one of those 3 enumerated values that we had up in the interface. Remember? So we can ask up front if order type is equal to So the way that we refer to that is, because it's static, we name the interface first, because that's where it's stored. We name the type of the enumeration field, which we called a traversal field, and then we can put after that dot one of the 3 possible enumerator values. And so pre-order was one of them. No capital O. All right. So what happens inside of here is big enough that for clarity, we're going to build a helper function to do it. So we'll build ourselves a pre-order function, and we'll pass in the root of the tree as we currently know it, and this info queue structure that's going to get the queue back. All right, so we'll come back and think about what that does in a little bit. But then we're going to basically repeat. That's totally not going to work the way I wanted it to. All right, the next choice is in order. And in that case, we're going to call a helper function that does the in order. And the last else, well, it's got to be the other one. But, why not? There might be additional traversal types that get added in some inherited version of this later on. So might as well go test for it anyway. Post order, we call our post order helper function. Give it info queue. And that will build up the queue for us. Okay, so by the time we reach the blinking cursor down here, regardless of which order we've asked for, now all the nodes in my binary search tree have been inserted into this info queue structure in the correct order by the traversal type that I have, right? So now this function's job is actually to return the iterator object. I'm going to make the iterator object. And we're once again going to use this trick of using an anonymous inner class. So this is going to be an iterator object of type T. Put in the constructor there with nothing in it. And right away, open and close curly braces, because we're going to define this nameless iterator object right here in place. Colin? Yeah, that's probably not going to work out so well. What should we do? Methods I've been using lowercase, right? That'd probably be more consistent. Thank you, Colin. Good catch. Style is very important for clarity and correctness in many cases. All right, so new iterator object here. And it's an iterator object, so it's got to at least have the has next and the next fields, right? So let's do a public Boolean method. Boolean has next. So how will we know if our item has a next object available in the iterator? It's this info queue that's keeping track of all the nodes. So if we've already been going through here, then we should be able to ask the queue, is there anything more in there, right? So if you remember back in the day when we were talking about queues, we always had an isEmpty method, right? And so if there's an object waiting still to be iterated, then this isEmpty should be not true, right? The queue should not be empty. So we want to return the not of infoqueue.isEmpty. Right? Is everybody okay with this shortcut here? Maybe putting an exclamation mark in front of this, right? Okay, that's easy. And then the important one is we need to be able to get objects back out of it. So this is a public method that returns type T, and it's called next. So if somebody calls next and it's already empty, that's going to be a bad thing, right? So we need to double check that. If not has next. We already wrote that up here, so we can just make use of that. If it doesn't have a new one, then we should throw some kind of exception here, right? Throw exception. Right. So this is not real Java code. This is, commentary. I'm not going to bother to type out the whole exception. That needs to happen, right? Otherwise, we just return whatever the next thing is, right? And we've got our nicely built queue that will give me the next item. And it was DQ was the name of our method from back in the day for being able to do that, right? So I'm skipping some little bits here, but you can go look those up in the book if you're curious. Otherwise, this is pretty straightforward. Okay, so far so good. What's the last thing we need? Who remembers what the interface is for an iterator? Like the fourth one we've written now. What do they all have? Has next, next, and remove. We need to be able to remove items, which sometimes screws things up, but that's got to be in here because the interface promises it. And it's assumed we are going to remove the one that's at that location. So what does it mean to remove an item that we've just gotten out of the queue that stores all the nodes that were in the binary search tree? I suppose technically it means we should go remove that item from the binary search tree, right? What does it mean to call remove on an iterator that we've just used to get all the nodes out of the binary search tree in a nice little list for us? Kind of complicated thinking about what that means. Even though the interface promises that this is an operation that has to be supported, that doesn't mean we actually have to do it. And in this particular data structure, it doesn't make a lot of sense to allow people to remove something out of the, it's not the same as it is in some of the simpler cases we've talked about. So that's okay. You can decide, I don't want to do that. I'm going to throw a new unsupported operation exception. And I can basically complain at the user and say, you can't do that. Unsupported remove attempt. All right? You don't have to say bad kitty if you don't want to, but, I feel like some kind of, more formal slap on the wrist is required for trying to move something from our binary search tree iterator. So don't actually use that version of code. I edit that out before you put that in your library. All right, so that's it. Kind of complicated, but each of the individual steps isn't so bad in isolation, right? Our goal here was to produce a getIterator function that's going to return a list of the nodes. And so we're using these helper functions to actually load the nodes up in the queue properly. We'll write those in a second. And then we return an anonymous inner class of the iterator that just walks its way through the queue data structure. Make sense? So this will allow us to be able to loop through the items in our binary search tree using any one of those three possible traversal schemes. Far so good? All right. Can you picture in your head what these helper functions, pre-order, in-order, and post-order, would probably do? I'm giving them the root of the tree, which remember is this binary search tree node structure. So it has data in the field, it has a left field, and has a right field. And I'm giving this queue in which I'm just supposed to insert each one of the items as I go through. Yeah, Katie? Yeah, so the ordering of the queue is going to totally boil down to the order in which I add the items into the queue one at a time, right? Do I add the item that I'm on in the root node first, or do I recursively add my left subtree first, right? That's going to be the difference between pre-order and in-order traversal, right? Except for us, it's been broken down into 3 different helper functions, and so we don't need to confuse those together. So these will be private helper methods. They're void. In order was what we called the first one, I think. Binary search tree node type T node is what's getting passed in here. And we're also giving it the linked queue data structure, again, of whatever type T is. Just call that queue, because why not? Safety first. We should always make sure that we don't have a null node here. If it is null, then there's really nothing to do here, because there's nothing to add. But if it's not null, then we can proceed. If this is an in-order traversal, then I'm going to recursively do what's in my left child. Then I'm going to enqueue the data at the node that I'm on, and then I'm going to recursively add the data that's in my right subtree, right? So beautiful recursive function here. In order node.getLeft queue. Add the thing that I've actually got right here. NQ was the name of that method from back in the day when we were doing that. And I want to get the info that's stored in the node that I'm currently on here. And then in order node.getRight. Right? So this is a recursive function. What's my base case? Yeah, node being equal to null is implicitly the base case. If node is equal to null, I don't enter the if statement, and this function does nothing and returns immediately. So my base case doesn't mean I always have to have an if statement that says if base case, then return, right? I still have a base case here. What is my recursive case? It's everything where the node is not equal to null. It's the main part of the body here. And do I have the smaller caller rule in control here? Yes, because the recursive calls to in order are getting the left or the right subchildren, so I'm always moving closer to the leaves of the binary search tree. I'm always making the problem smaller each recursive call. All right, can you envision now what the similar methods for pre-order and post-order will do? They look just like this, but have these 3 statements in a different order, right? Pre-order is going to do the NQ first, and then the left, and then the right. And post-order is going to do the left first, then the right, and then NQ this item last. Right? That's what makes the different traversals. And as I recurse through the tree in those different ways, I get the 3 different possible queues. I get these 3 possible results out. Make sense? So pretty easy to construct those other 2 helper functions, and we've got ourselves the iterator. All right, so what's that leave then? From our original binary search tree functions, the only really important things we need to worry about still are add and remove. Is full and is empty are pretty much trivial. All right? So we'll talk about add to our binary search tree and remove on Monday, and we'll finish off our binary search tree section. Okay? Here is your QR code for today. Have a great weekend. Get started on your project research. Bring questions about the project on Monday. And don't forget the reading quiz Monday morning. Okay? Have a great weekend, everybody.